Hi, in this video we're going to learn about simplifying rational expression. This is the introduction to your lesson for rational function. After simplifying, we are going to learn about operations of rational expression and then we will move to function. But let's focus first. Most importantly, you should be able to simplify correctly rational expression. And that should be your objective. You should be able to simplify rational expressions such as the following. Before we begin, let's review some terms. Polynomial. It is the sum or difference of monomials. Rational expression, a fraction whose numerator and denominator are polynomials. Domain of a rational expression. The set of all real numbers except those for which the denominator is 0. In a rational expression or in a fraction, the denominator cannot be a 0. Since we are dealing with variable, there might be different values of x or variable that will make the denominator 0 and it's not part of the domain, the value that makes the function undefined because the denominator becomes 0. Reduced form, or actually simplest form, is a rational expression in which the numerator and the denominator have no factors in common. Now, how do you simplify rational expressions? There are two ways. It might be that you just directly simply divide out the common factors or canceling the common factors. Or you may need to factor the numerator and denominator and then divide out the common factors. Let's check the very first ways wherein you just directly divide out common factors. How do you divide out common factors? Identify any factors which are common to both the numerator and the denominator. Look at your example, 5x divided by 5 times x minus 7. The numerator and the denominator have a common factor. The common factor is 5. What you can do, you just actually divide out the common factors. The 5's can be divided since 5 divided by 5 is equal to 1. The x remains in the numerator. X minus 7 remains in the denominator. So 5 becomes 1. X remains as a numerator. X minus 7 remains as a denominator. So it's just simply canceling your common factors or dividing them out. And your answers are the one not crossed out. X over x minus 7. Now, how do you do the other way wherein you need to factor the numerator and denominator and then afterwards you divide out or you cancel? First, you need to factor the numerator and then factor the denominator and then divide out the common factors and write the simplified form. Let's have your example, 3x squared plus 9x all over 12x cubed. How do you begin? First, look for common factors to both terms in the numerators. In our numerators, you have 3 is a factor of both 3 and 9. On your another thing is x is a factor of both x squared and x. So therefore, our common factors are 3 and x. Factor the numerators using 3 and x. After writing it down, when you say factor, what do you multiply to 3x to get 3x squared? Actually, you need x. X is actually the remaining factor after factoring out 3x from 3x squared. When you factor out 3x from 9x, you actually is left with 3. Or shall we just say, what do you multiply to 3x to get 9x? You need 3. And we just factored your numerator. Copy your denominator, but we also need to factor it. Now, look for common factors to the terms in the denominator and then factor. The denominator only has one term, the 12 and x cubed can be factored. The 12 can be factored into 3 times 4. The x cubed can be written as x times x squared or x times x times x. And here it is. Now, What do you do next? You now divide out or cancel common factors. Divide out the common factors. In this case, the common factors divided becomes 1. 3 is cancelled, and also x. You cannot cancel the terms inside the parentheses unless there is exactly the same parenthesis x plus 3 on the denominator. We are only able to cancel 3 pairs of 3 and pairs of x. Now, whatever is not cancelled out or not divided out, it is your simplified form, x plus 3 on the numerator and 4x squared in the denominator. We were able to simplify your expression into its simplified form or reduced form. Okay. Now, let's try some more examples. Simplify the following rational expressions. Let's begin with number 1. How do you simplify? First, you can do factoring of the term. 9 has factors of 3 times 3. X squared is x times x, and then y times z. 24 is 3 times 4 times 2, or 2 times 2 times 2 times 4. No, 4 times it's 8 times 3, so you have 3 times 2 times 4, or 3 times 2 times 2 times 2. Nope, we only use 3 times 8. X, y, and then there's 2z. After factoring, you divide out common factors, or just simply saying, just cancel out the same factors on the numerator and the denominator. So we have 3, x, y, and then z. Whatever is not divided out or cancelled out, that will be your answer. And that's your simplified form. You have 3x on top, and which is the numerator. 3x will be your numerator, and then 8z for your denominator. And that is your final answer. A little tricky on your factoring. You see how, try to consider or try to see which one actually works. Okay, now let's try number 2 problem. A plus 3 divided by a squared plus 4a plus 3. On your numerator, it does not simplify anymore. You will have a hint that the factor of the denominator, one of it is a plus 3. Actually, since 3, we actually presume that the factor below is a plus 3 multiplied to a plus 1, because 3 plus 1 is 4. Factor out the denominator, and here it is. By FOIL, we can check if our guess of the numerator of the factor is correct. Like I said, the numerator may be a hint of one of the factor, and then you now have a hint what factors of 3 will add up as 4. So actually it's just 1. 3 times 3 is 1. Your inner is 3a, your outer is 1a. 3 plus 3a plus 1a is 4a. Therefore, that's your factor. Cancel out or divide out the common factors, a plus 3. Remember, if everything is cancelled out, if you don't want to separate it by dividing out, whenever everything is cancelled on top, there is 1 left. A plus 1 stays as a denominator. So that's your answer. Your simplified form is 1 over a plus 1. Let's try another example. Number 3, you have 3x minus 15 all over x squared minus 7x plus 10. Here you can factor out 3, so it becomes x minus 5 after factoring out 3. Below is gonna be 10 is 2 times 5. Since it's positive, it means your factors should be both negative to come up with 7. Negative 2 and negative 5 will add up as negative 7. So here they are. We factor out only 3 on the numerator. Like I said, the factors of 10 is 2 times 5. Both should be negative, so that when you check by FOIL, it gives you a negative 7x. We can now divide out or cancel the common factor. You can actually write it this way to clearly show that there is a 1, like if nothing is left, but since 3 is left, so 3 times 1 is 3 anyway. So the x minus 5s are the ones cancelled out or divided out, and that should be your answer. Whatever is uncancelled, it's 3 over x minus 2. Sub number 4. Now it's going to be complete factoring. 15 should be 3 times 5. If 2 is negative, then 5 is negative, because negative 5 plus 3 is negative 2. Here below is negative 12. You know what? Let's write it down. 3 and then 5 to come up with 15. To come up with negative 2, 5 should be negative. To come up with 4, the possible factor should be 4 times 3, not 6 times 2. Since the middle term is negative, it should be 4 should be negative. And then you just pair those factors with x's. And here they are. We are going to factor the numerator and then the denominator in parenthesis form. The first pair should be x plus 3, x minus 5 on your numerator. Denominator is x minus 4, x plus 3. Now it's very clear. We can cancel a common factor or divide it out. X plus 3. Whatever is not cancelled, that's your answer, which is the simplified form. You don't need to write your parentheses. Parentheses is just showing a separation between binomials and showing that the operation is multiplication. Okay, let's proceed. This is gonna be the last. So this is gonna be tough, but actually it's a little bit tricky. A problem might stun you that it is very difficult, but actually look at your pattern. We are going to factor the numerator and the denominator. 14, 35, 21 looks familiar. Actually, they are factors of 7. 12, 30, and 18 are actually factors of 6. If you factor out 7 here, you have 2, 5, 3. If you factor out 6 here, you have 2, 5, 3. Amazingly, you have your factors here. Okay, this is supposed to be 5. Let me fix it. Next, and now you can divide out common factors. Again, it's 5. And it's very clear. We can now cancel your trinomial common factors, and actually the answer is just 7 over 6. Okay, now there are some caution. There is a restriction on rational expression. As I mentioned earlier, the domain of a fraction, the denominator of a fraction cannot be 0. So if you have a variable, the x should not make the denominator becomes 0, because it becomes undefined. Let's say you have here an example for what value of x is the rational expression x squared minus 2x minus 15 all over 4x minus 20 be undefined. Well, if the expression is quite complicated, there is a sure way of mathematically you just equate the denominator into 0, because we don't want the whole denominator become equal to 0. So it is undefined for any value of x which makes the denominator 0. In equation form, you just equate it to 0. Through this, we can find out what value of x makes the expression 0, and then solve. Apply your properties of equation, add both sides by 20. You have 4x is equal to 20, divide both sides by 4, and your x is 5. Therefore, x cannot be 5. The restriction is that x cannot be equal to 5 because the given rational expression becomes undefined because the denominator becomes 0 if x is equal to 5. Now, let's have more examples. What are the excluded values of the variables for the following rational expressions? Let's try number 1. Actually, you don't have to solve. It's very obvious. Y or 0, y and z cannot be 0. Otherwise, the rational expression will be undefined. Next, number 2. Here we need to do a little work. We will equate 2x minus 12 into equal to 0. Add both sides by 12. You have 2x is equal to 12. Divide both sides by 2. X is 6. Therefore, x cannot be 6 or the rational expression becomes undefined. We have the last, c squared plus 2c minus 8. Again, it's a quadratic expression. If we equate that to 0, it becomes equation. And then to solve, there are two possible solutions. We can do factoring. What factors of 8 gives you a sum of 2? So actually 4 times 2, and 2 should be negative because 4 minus 2 is positive 2. We pair it up with c and close with a parenthesis to show that these are the factors. And so by zero factor property, we will equate both factors to 0, and that we can find values of c's. There are two possible values. We add 2 on both sides for the first case. We subtract 4 on both sides on the second factor. Therefore, we found that our first factor c is equal to 2, and the second one c is negative 4. Therefore, on our given rational expression, c cannot be 2, and c cannot also be negative 4. Otherwise, the rational expression will be undefined. Okay? You should have learned how to simplify rational expression, and that you should always remember that there is a restriction, that there are possible values of the variable that will make the rational expression undefined. If you need to review, you can watch this video again. Thank you.